Hey guys, welcome to Math for Kids by a Kid. In today's video, we're going to learn how to divide a polynomial by a binomial. And so, many of you from grade 10 or grade 9 know how to divide a polynomial by a monomial. And so, just as a recap, I'll just show you an example of that. So let's say you have 12x squared minus 6x plus 9, all divided by 3. This is really the same as 12x squared divided by 3 minus 6x divided by 3 and plus 9 divided by 3, which would equal 4x squared minus 2x plus 3. So as you can see, this is very straightforward. But in today's video, we're going to learn how to do something that looks like this. So 12x squared minus 6x plus 9 divided by 3x minus 2. So there's two terms instead of one. So in doing these kind of problems, we need to set it up first. And so we're going to set it up like we would any long division problem. So we've got the product under the division sign, and then we've got the divisor on the left of the division sign. And so the first step is we're going to compare the first term of the product and the first term of the divisor. And we need to see what we can multiply 2x by to give us 6x squared. So to figure that out, we can simply just divide 6x squared by 2x, which equals 3x. And it's easy to just look at it and say it's 3x, so you don't even have to do this. And so we're going to write 3x above. And I'll just erase this sign here. And what we're going to do is we're going to multiply 3x by 2x minus 3. And so I'll just write this on the side using distributive property. You get 6x squared minus 9x. And we're going to take 6x squared minus 5x plus 7 and subtract 6x squared minus 9x from it. So, like this. And notice that I put brackets around the term when I subtracted. And so this leaves us with 4x, because keep in mind, the signs of each of these terms change because there's a negative in front of it. So it's minus 6x squared plus 9x. And so that means the 6x squared cancel out, and negative 5x plus 9x is 4x. And so we're going to bring down the plus 7. And so like we did with 6x squared and 2x, we're going to figure out what we can multiply 2x by to get 4x. And so that's 2. And like before, we're going to multiply 2 by 2x minus 3, which is 4x minus 6. And we're going to subtract it from 4x minus 7. And again, always remember, put brackets around the terms when you're subtracting. And that leaves us with 13. And so, when we're writing this out, we say that 6x squared minus 5x plus 7 is equal to 2x minus 3 times 3x plus 2 plus 13. This number that you get here is the remainder. And we can also write this as 6x squared minus 5x plus 7 divided by 2x minus 3 is equal to 3x plus 2 plus 13 over 2x minus 3. So I'll just write out the form that each of these are. So this is in the form of P equals Q D plus R, and Q simply stands for quotient, D is for divisor, R is for remainder, and P is product. And this form here is product over divisor equals the quotient plus the remainder over the divisor. And I just want to show you how these formulas are equal to each other. So P equals Q D plus R. And we're dividing both sides by D. So, like this. And so this is really the same as q times d over d plus r over d. And we can see here that there's d on the top and bottom, so this cancels out, and then we're left with q plus r over d. And some questions in your textbook may ask you to find out if this binomial is a factor of this polynomial. What they really mean is that they want you to divide the polynomial by the binomial and see if the remainder is 0. If the remainder is 0, then that binomial is a factor. But if the remainder is not 0, then that binomial is not a factor of the polynomial. So I'll do an example here. So we're being asked if x minus 3 is a factor of the polynomial 2x squared minus 5x plus 2. And so we're going to set it up, like we did in the last problem, with the polynomial under the division sign, and then the divisor on the left of the division sign. So 2x squared divided by x equals 2x. X times 2x is 2x squared. So we'll write 2x here. And 2x times x minus 3 is 2x squared minus 6x. Subtract it from the polynomial. These cancel out. Negative 5x plus 6x is x. We bring down the plus 2. X times 1 gives us x, so we write plus 1 up here. And then 1 times x minus 3 is x minus 3. So subtracted from x plus 2, and 2 plus 3 is 5, and so this is our remainder. And so we can see that the remainder is not equal to 0, and we said earlier that if the remainder is not 0, then the binomial is not a factor of the polynomial. And so in this case, the remainder is 5 and not 0, so therefore x minus 3 is not a factor of the polynomial 2x squared minus 5x plus 2. The degree of the divisor must be less than the degree of the polynomial. So let's say we're dividing. The degree of the divisor has to be less than the degree of the polynomial. So the reason why we were able to do all the problems above was because the degree of the divisor was less than the degree of the polynomial. So in the example above, it was x minus 3 The degree of the divisor must be less than the degree of the polynomial. The degree of the divisor must not be greater than the degree of the polynomial. And so many of you are familiar what the degree of a polynomial is, and just as a recap, it's just, so I'll take the polynomial. To find the degree of a polynomial, you simply have to find the term with the highest degree, which is the term with the highest exponent on its variable. So you have 2x squared and negative 5x, and 7 times x to the power of 0. X to the power of 0 is 1, and 1 times 7 is 7, and so it's not mandatory to write the x to the power of 0, but you can certainly add it in there if it helps you find the degree of a polynomial easier. And so we can see here that the degree of the first term is 2, the degree of the second term is 1, and the degree of the third term is 0. And so we can see that 2x squared has the highest exponent on its variable. And so we say the polynomial has a degree of 2 because 2 is the exponent on the variable. And so in this example, the degree of x minus 4 is 1 because of this exponent here. It's invisible. You don't have to write it, but you can write it in there. And so if we were to divide x squared minus 4 by x minus 3, it's impossible because the degree of the polynomial is 1 and the degree of the divisor is 2, and so that's not allowed. Like, this degree has to be greater than the degree. Oh my god. The degree of the divisor must not be greater than the degree of the polynomial, and the degree of the remainder must be less than the degree of the divisor. I'll show you an example of these rules. So we can divide 2x squared minus 5x by x minus 3 because the degree of this polynomial is 2 and the degree of this binomial is 1. But if we were to divide x minus 4 by x squared plus 3, it's impossible because the degree of the divisor, which is 2, is greater than the degree of this polynomial, which is 1. So this is not allowed. I'm going to go back to previous examples to show you about the degree of the remainder. So in this example, the degree of the remainder is 0 because this is the same as 5 times x to the power of 0. X to the power of 0 is 1, so you don't have to write it in, but I'm writing it in to show you. So the degree of the remainder is 0, and the degree of the divisor is 1. And so the degree of the remainder will always be less than the degree of the divisor. Thanks for watching, guys. I'll see you soon.